On April 26, 2018, an explosion and subsequent fire at a refinery in Wisconsin caused 36 injuries and $550 million in damages. The explosion, during a planned maintenance shutdown, released 39,000 pounds of flammable hydrocarbon vapors and punctured an asphalt tank, leading to fires and evacuation of over 2,500 residents. The nearby hydrofluoric acid storage tank remained intact, avoiding a potential catastrophic release. What happened? Operators were shutting down the FCC unit, following revised procedures that included draining liquids, purging systems, and preparing for chemical cleaning. The shutdown process involved balancing pressures in critical systems to prevent hazardous air and hydrocarbon mixing. At 9:58 a.m., during the shutdown, pressure imbalances allowed air to mix with hydrocarbons in the primary absorber and sponge absorber vessels. This resulted in an explosion that sent over 100 pieces of debris across the refinery, shaking buildings over a mile away. The debris punctured an asphalt tank, releasing approximately 17,000 barrels of hot asphalt, which began flowing outside the containment area. At around 12 p.m., the spilled asphalt ignited, leading to multiple fires in the refinery. Emergency responders worked to contain the fires, while the city of Superior evacuated residents within a 2-mile radius and issued advisories for nearby areas. Smoke and concerns about toxic hydrofluoric acid prompted a shelter-in-place advisory in Duluth, Minnesota, at 8 p.m. The fires were extinguished by midnight, and evacuation orders were lifted the following morning. What are the root causes? Operational gaps, failure to maintain a reactor steam barrier to separate air and hydrocarbons. Equipment issues, erosion of a catalyst slide valve allowed air to enter hydrocarbon-filled equipment, creating a flammable mixture. Knowledge deficiency, operators lacked training and adequate understanding of FCC shutdown hazards, and procedures deviated from licensor guidelines. Material vulnerability, the vessels involved were made from brittle steel, which shattered under explosive force, exacerbating the damage. Key lessons and recommendations. 1. Enhanced safeguards, implement reactor steam barriers, proper purging of oxygen from systems, and robust monitoring of critical parameters during shutdowns. 2. Equipment upgrades, replace susceptible materials like brittle steel and develop better maintenance programs for slide valves. 3. Training, introduce rigorous operator training programs, including simulations and updated manuals, to ensure alignment with best practices. 4. Process reviews, regularly evaluate and update operating procedures in consultation with licensor and industry standards to address transient operation hazards. 5. Emergency preparedness, improve response strategies for incidents involving materials like asphalt and pyrophoric substances. Thank you for watching.